This is 3.5, graphing linear equations in slope-intercept form. So, slope is m, which is rise over run, and to find how much our graph is rising, we find the difference in the y values over the difference in the x values, which is how much it's changing side to side. So this would be rise, how much it goes up or down, and run is how much it goes side to side between points. So this is the formula we use to find slope. So if I have this graph here, I have point 1 and point 2. I'm going to use my formula, y2 minus y1 over x2 minus x1, and I take y from point 2, that is 2, minus y from point 1, which is negative 1. So that's 2 minus negative 1 over x from point 2, which is 3, minus x from point 1, which is negative 2. So that's 3 minus negative 2. When I have a minus a negative, that is the same as adding. So this is 2 plus 1, which is 3, and 3 plus 2, which is 5. So the slope of this line is 3/5. That means I go up 3 and to the right 5 to get from one point to the next. Here I have my points 1 and 2. Using my formula, this would be negative 1 minus 3 over 2 minus negative 1 to get negative 4 over 3. We can confirm that our slope is correct by counting on the graph, and I know just by looking at this one it's going to be negative, because as I read the graph from left to right, it points down. A couple important notes. The slope of a horizontal line is 0. This will give the rise does not change. So it would be like 3 minus 3 over 0 minus 1. And 0 divided by a number is 0. So this is a slope of 0. And the slope of a vertical line is undefined. This would be a number divided by 0, and we cannot divide by 0, so we say it is undefined. For slope-intercept form, that is y equals mx plus b, where m is slope, and we know how to find slope from up here, and b is the y-intercept, so that is where it crosses the y-axis. So we're going to identify the slope and y-intercept. Identify means just point out this is this and this is this. We don't have to solve, we don't have to graph. So let's talk through a couple of them, and I have a whole bunch of examples to show. So here in y equals 2x plus 3, m, so the number in the m position, which is the number in front of x, is 2. And my b is a positive 3. This one will work similarly. And here I have a negative 4 in place of m, so my slope is negative 4. I have 3x minus 5, so b, my y-intercept is a negative 5. This one is y equals x minus 3, and if there's no number written in front of x, we know that there's an invisible 1. So my slope is 1, y-intercept negative 3. This one, y equals 2x. I don't have any plus or minus on the end, so it is a plus 0, so my y-intercept is 0. And here I have y equals 3. I do not have an x term, so my slope is 0. 0 times x is 0, and that does not change anything. It would be 0x plus 3. So our slope is 0, and the number is the y-intercept. And now we're going to graph a couple of lines. To graph from slope-intercept form, we are first going to plot the y-intercept, and then we are going to use the slope to count on the graph from one point to the next, and then connect them with a line. So if I graph y equals 2x plus 3, 2 is my slope and 3 is my y-intercept. So I go up to 3 and put a dot. Then from that y-intercept, I count with my slope. So it's a 2, I rewrite that as a fraction, 2 over 1. So that is rise over run, up 2 to the right 1, and put a dot. Also, I know that a negative divided by a negative is a positive, so I'm going to have a negative 2 and a negative 1. So that is down 2 to the left 1. And keep going down 2 to the left 1. And then I connect the line. Here's a second equation to show y-intercept is negative 1. So it crosses here at negative 1, and my slope is 1/3. So that means I go up 1 to the right 3, up 1 to the right 3, or down 1 to the left 3, and then connect with a line.